Euclid, sometimes called Euclid of Alexandria to distinguish him from Euclid of Megara, was a Greek mathematician, often referred to as the father of geometry. He was active in Alexandria during the reign of Ptolemy I. His Elements is one of the most influential works in the history of mathematics, serving as the main textbook for teaching mathematics from the time of its publication until the late 19th or early 20th century. In the Elements, Euclid deduced the principles of what is now called Euclidean geometry from a small set of axioms. Euclid also wrote works on perspective, conic sections, spherical geometry, number theory and rigor. Euclid is the anglicized version of the Greek name epsilon kappa lambda epsilon iota delta eta sigma, which means renowned, glorious, life. Very few original references to Euclid survive, so little is known about his life. The date, place and circumstances of both his birth and death are unknown and may only be estimated roughly relative to other figures mentioned alongside him. He is rarely mentioned by name by other Greek mathematicians from Archimedes onward, who usually call him sigma tau omicron iota chi epsilon iota omega tau eta sigma. The few historical references to Euclid were written centuries after he lived by Proclus c. 450 AD and Pappus of Alexandria c. 320 AD. Proclus introduces Euclid only briefly in his commentary on the Elements. According to Proclus, Euclid belonged to Plato's Persuasion, and brought together the Elements. Drawing on prior work by several pupils of Plato, Proclus believes that Euclid is not much younger than these, and that he must have lived during the time of Ptolemy I because he was mentioned by Archimedes. Although the apparent citation of Euclid by Archimedes has been judged to be an interpolation by later editors of his works, it is still believed that Euclid wrote his works before those of Archimedes. Proclus later retells a story that, when Ptolemy I asked if there was a shorter path to learning geometry than Euclid's Elements, Euclid replied, "There is no royal road to geometry." This anecdote is questionable since it is similar to a story told about Menechmuse and Alexander the Great. In the only other key reference to Euclid, Pappus briefly mentioned in the 4th century that Apollonius spent a very long time with the pupils of Euclid at Alexandria, and it was thus that he acquired such a scientific habit of thought. c. 247–222 BC. A detailed biography of Euclid is given by Arabian authors, mentioning, for example, a birth town of Tyre. This biography is generally believed to be completely fictitious. Because the lack of biographical information is unusual for the period, some researchers have proposed that Euclid was not, in fact, a historical character and that his works were written by a team of mathematicians who took the name Euclid from the historical character Euclid of Megara. However, this hypothesis is not well accepted by scholars and there is little evidence in its favor. Elements. Although many of the results in Elements originated with earlier mathematicians, one of Euclid's accomplishments was to present him in a single, logically coherent framework, making it easy to use and easy to reference, including a system of rigorous mathematical proofs that remains the basis of mathematics 23 centuries later. There is no mention of Euclid in the earliest remaining copies of the Elements, and most of the copies say they are from the edition of Theon, or the Lectures of Theon, while the text considered to be primary, held by the Vatican, mentions no author. The only reference that historians rely on of Euclid having written the Elements was from Proclus, who briefly in his commentary on the Elements ascribes Euclid as its author. Although best known for its geometric results, the Elements also includes number theory. It considers the connection between perfect numbers and Mersenne primes, the infinitude of prime numbers, Euclid's lemma on factorization, and the Euclidean algorithm for finding the greatest common divisor of two numbers. The geometrical system described in the Elements was long known simply as geometry, and was considered to be the only geometry possible. Today, however, that system is often referred to as Euclidean geometry to distinguish it from other so-called non-Euclidean geometries that mathematicians discovered in the 19th century. Other works. In addition to the Elements, at least 5 works of Euclid have survived to the present day. They follow the same logical structure as Elements, with definitions and proved propositions. Data deals with the nature and implications of given information in geometrical problems. The subject matter is closely related to the first 4 books of the Elements. On divisions of figures, which survives only partially in Arabic translation, concerns the division of geometrical figures into 2 or more equal parts or into parts in given ratios. It is similar to a 3rd century AD work by Heron of Alexandria, Catoptrix, which concerns the mathematical theory of mirrors, particularly the images formed in plane and spherical concave mirrors. The attribution is held to be anachronistic, however, by J.J. O'Connor and E.F. Robertson, who named Theon of Alexandria as a more likely author. Phenomena, a treatise on spherical astronomy, survives in Greek. It is quite similar to On the Moving Sphere by Autolycus of Pitane, who flourished around 310 BC. Optics is the earliest surviving Greek treatise on perspective. In its definitions, Euclid follows the Platonic tradition that vision is caused by discrete rays which emanate from the eye. One important definition is the fourth. Things seen under a greater angle appear greater, and those under a lesser angle less, while those under equal angles appear equal. In the 36 propositions that follow, Euclid relates the apparent size of an object to its distance from the eye and investigates the apparent shapes of cylinders and cones when viewed from different angles. Proposition 45 is interesting, proving that for any 2 unequal magnitudes, there is a point from which the 2 appear equal. Pappus believed these results to be important in astronomy and included Euclid's Optics, along with his Phenomena, in the Little Astronomy, a compendium of smaller works to be studied before the Syntaxis of Claudius Ptolemy. Other works are credibly attributed to Euclid, but have been lost. Concubux was a work on conic sections that was later extended by Apollonius of Perga into his famous work on the subject. It is likely that the first 4 books of Apollonius's work come directly from Euclid. According to Pappus, Apollonius, having completed Euclid's 4 books of conics and added 4 others, handed down 8 volumes of conics. The conics of Apollonius quickly supplanted the former work, and by the time of Pappus, Euclid's work was already lost. Porisms might have been an outgrowth of Euclid's work with conic sections, but the exact meaning of the title is controversial. Pseudaria, or Book of Fallacies, was an elementary text about errors in reasoning. Surface loci concerned either loci on surfaces or loci which were themselves surfaces. Under the latter interpretation, it has been hypothesized that the work might have dealt with quadric surfaces. Several works on mechanics are attributed to Euclid by Arabic sources. On the Heavy and the Light contains, in 9 definitions and 5 propositions, Aristotelian notions of moving bodies and the concept of specific gravity. On the Balance treats the theory of the lever in a similarly Euclidean manner, containing 1 definition, 2 axioms, and 4 propositions. A third fragment, on the circles described by the ends of a moving lever, contains 4 propositions. These 3 works complement each other in such a way that it has been suggested that they are remnants of a single treatise on mechanics written by Euclid.